multiply matrices, the dimensions become important. I'm actually not sure if you're going to run into a problem at all with what they teach you here, but I know next year in Advanced Algebra 2, you have to be very aware of the dimensions when you're multiplying. So you have to make sure that A and B are defined before you can multiply them. If it's defined, then you can multiply them. So if so, give the dimensions of A, B. So defined just means when you write the dimensions of each of the matrices that you're trying to multiply. If this number, the inside numbers, are the same, that means that they're defined. So I'd say these numbers have to be the same in order to multiply. So these two matrices are defined. Okay? So I would say yes. And then it says, if so, give the dimensions of A times B. What do you think? Does anybody have a guess as to what the dimensions of A times B might be?
15 times.
What?
15 times.
No, you don't. No, you don't multiply the dimensions. It's a good guess, though. What do you? It's something to do with the numbers that are here. What do you think, Drew?
6, 3 times 2.
No, you don't. No. I know you don't know. I just was seeing if anybody might guess. Yes, Haley. Oh, I'm sorry.
3 times 5 is 2.
Close, close.
3 times
3 by 2. So if they are defined, then these would be the dimensions of your product. And it helps you in knowing, well, like what size to set up your answer. Kind of helps. So the dimensions of the product would be 3 by 2. What always comes first in the dimensions?
RC.
RC. Rows and columns, right? Rows and columns. So that would be 3 rows, 2 columns. Okay? So we're going to multiply matrix A by matrix B. Is it possible? No. It won't work. So because these numbers are not the same, it's not defined, so you don't even bother. Nope. Okay? So let's go into, now that we've kind of talked about dimensions a little bit, let's go into multiplying. So we're going to multiply A times B. So let's just automatically just write down the dimensions. 2 by 2, 2 by 2. Are they defined? Can we multiply them?
Yeah.
Yes, I can multiply them. And what is the dimensions of my answer going to be? I'm just going to write this over here. The answer will be a 2 by 2 because of the outside numbers. It kind of helps me just know how to set up my answer too and what it should be when I'm done. Now, I'm going to start to teach you this. Actually, I want you guys to draw these like lines here. The first one I'm going to do very laid out as a teaching one. You don't always have to do it that way, but I want you to do it too. So we're going to make a really big one here. And leave yourself some room to write the actual answer once we're done here. Now, I'm a color person. I like to use color. When you multiply 2 matrices together, it's not difficult. It's just a little bit meticulous. What you do is you multiply each row by each column. So I'm going to just put, you don't have to do this, but I'm just going to say, okay, I'm going to take this row and I'm going to multiply it by that column. So just look at that for a second. Where do you think that element will go in my new matrix? Where do they kind of intersect? They would intersect in this upper left corner, wouldn't they? If I did this and this. I mean, just kind of think about that. You don't necessarily have to do it. But here's what you do. If I multiply this row by this column, I'm going to multiply this element by this element. So I have 2 times 1, and I'm going to add to it -3 times 3. So I want you to write that out. That's going to be the top left spot of my new matrix. Do you all see what I did there? Okay. So I'm multiplying each row by each column. So I still have to multiply the top row by this column. And so that'll be my upper right element. So I do 2 times -4 plus -3 times -2. Top row, right column. You see where we're going with this? Okay, so I did the top row in both the columns. Now I have to do the bottom row in both columns. So I'm going to take, doesn't matter, I'll just do blue by, so bottom row by first column. So I'm going to do 1 times 1 plus 5 times 3. Then I have to do what? What's the last thing I have to do? Bottom row by
Negative.
by the right column, correct? Bottom row by that column. I know it's a little weird looking, but 1 times -4 and 5 times -2. 1 times -4 plus 5 times -2. Then we go and simplify each spot, and that'll be our new matrix. Okay? So A times B is going to actually end up to be, what's 2 plus -9? -7. Then in this spot, I have -8 plus 6. Hold on. Did I do that right? Because I wrote it different down here. Yep, 2 times -4, -3. Okay, so when -8 plus 6 is -2, correct? Okay, and then this one here, 1 plus 8 is what?
15.
Oh, 16 here. Just checking. I even wrote that down. Okay, -4 plus -10. -14. See how it's a little bit different than adding or subtracting? Yeah, it's not bad. Okay, so that's those two multiplied together. So now we're going to do it again. This is a 2 by 2, and this is a 2 by 2. So I can multiply them, can I? Yes, I can. My answer is going to be a what? A 2 by 2. So we're not even going to do the long drawn out thing. We're just going to talk ourselves through it. Okay? This is going to be my answer here. So, first row by first column. Yes?
I'm confused, like, why are the negative, you have, like, -2 and -3.
No, that's just the dimensions. No. I'm just like, this is a 2 by 2, this is a 2 by 2. Yes, I can. I wasn't pointing to those intentionally. Okay? So we're going to multiply the first row by the first column. What is, watch, -3 times 1 is what? -3 plus 3 times -3, which is -9. So we have -3 plus -9. -12 will be the first element. Then I'm going to do the first row by the second column. -3 times 5 is what? -15 plus -6. That's my second element. So now I'm going to do the bottom row by the first column. 1 times 1, 1 plus 6. 7. And then bottom row times the second column. 1 times 5 is 5, plus 4. Okay. Questions? Yes.
When multiplying the rows in the column, you said 1 times 5. Could you do negative 2 times 5 and then have 1 times negative 2? Or is there a certain way you have to multiply?
Well, see, if you did that, negative 2, you have to go in that order. Because if you did negative 2 times 5, that's negative 10. Plus negative 2 would be negative 12. It's not the same number.
So kind of outside the in.
Kind of, if you want to look at it like that, yeah. Okay? Other questions? All right, now they get kind of weird looking, but it's still doable. Let's talk about the dimension. What's the dimensions of this one? Let's label this A and this B. What's the dimensions of A?
2 and 2.
Rows by column, so it's 1 by 2, correct? And then this is a what? So I can multiply them, can't I? And my answer is going to be a what?
1 by 1.
A 1 by 1. Oh, it's really weird looking, I know, but it is. So it's just going to be a little tiny matrix, and we're just going to have one number in there. So remember, in your head, you're doing rows by columns, correct? Well, I only have one row by one column, don't I? So it makes sense then. I'm just going to have one number. 5 times negative 3 is negative 15 plus negative 2. What's my answer?
Negative 17.
Rows by columns. Okay? So what's the dimensions of A here?
2 by 1.
I'm going to write A times B there. So this is 2 rows by 1 column, and this is what? 1 row by 2 columns. I can multiply them, and what's my answer going to be?
2.
A 2 by 2, which seems really weird, doesn't it? So remember, you do rows by columns. Well, I have 2 rows by 2 columns, don't I? Okay? So negative 3 times 2. That's all I can do. This row by this column is negative 6. That's my first element. Just take your time with it. Then I have to do this row by the second column. Negative 3 times 1 is negative 3. Top row by second column. Bottom row by first column is what? 4 times 2 is 8. And bottom row by second column is 4. Cool, isn't it?
Yeah.
That's all there is for notes.